Right. Thanks, guys. It's an absolute pleasure to be back at Polkadot Decoded. It's been a year since we've done our last talks, and we've had lots of development within CESS and within each of our ecosystems. So it's a pleasure for me to be here today and share with you what our developments within our ecosystem have been. Thank you. OK, so for those of you that don't know CESS, CESS is Cumulus Encrypted Storage System. We're a decentralized storage provider, but we differ because we're decentralized providers for the commercialization track. So we focus on a decentralized storage protocol for large-scale commercialization. So let's have a look at the CESS Cloud Data Network. It's split into three different parts. The first part of the CESS network is our storage functionality, our decentralized storage functionality. Now, this can be plugged in to your chain. We're cross-ecosystem, cross-chain. We're chain agnostic. So you can't just have this functionality serving you. Following, we have the decentralized cloud data network infrastructure. This is where all our blockchain technologies lie. This is where we have our proof schemes, our new algorithms, our new incentivization mechanisms, and that's where all the beauty of the coding lies. And finally, we have the CESS ecosystem. It's one of our visions to grow a very robust and diversified ecosystem. This is not only going to benefit CESS, but it's also going to benefit our partners, the DApps that are building within CESS, but ultimately it's going to benefit you as a user. So first, we must have an overview of what CESS is and the advantages that we can provide to the commercial storage track. So CESS is the first full-stack decentralized storage solution for large-scale commercial enterprise needs, commercial-grade applications. The CESS network is optimized for processing high-frequency, dynamic data, and it enables the real-time sharing of data with our users. And it safeguards its users' data ownership, its privacy, and its assets at the same time. There's more than one advantage to CESS, this full-stack solution. So CESS is fully decentralized. We have disaster recovery proofing, so we can guarantee that we're going to have your data stored safely and secured, regardless of the circumstance. We have a millisecond data retrieval. This is a point that is very important to scalability at the moment. We provide mass storage services, and we have a maximized use of our storage space. This is very important because so many protocols at the moment have lots of idle resources. So we find ourselves wasting resources that are of value to our company, to our miners especially, to our partners. We provide a full data ownership protection, and we also provide data privacy protection. So some of the industry pain points within decentralized storage are data vulnerability. We find many times that storage miners will quit their role as a storage miner. And when they quit, we lose our data along that. So we're losing our assets, we're losing our digital assets, our information is being lost with these miners quitting. Sometimes we have unexpected node failures. There's hacking attempts. There's internal leaks. Many protocols have an inefficient use of storage space. This happens because there's no cloud pooling technologies. It's wasted resources at the end of the day. Slow data retrieval. We have this because there's a lack of indexing functionality across other protocols. And this makes it to be not a very commercially applicable use. There's limited API capabilities, and there's a lack of infrastructure for these protocols to run smart contracts as well. CESS, on the other hand, has tackled each and every one of these needs one at a time. So we provide a high data assurance, the highest data assurance that there is at the moment in decentralized storage. We've done this through the implementation of proof of data reduplication and recovery and proof of dynamic data, both key core technologies, proprietary technologies to CESS. We also have a storage space maximization technology. So we call this the smart space management system. We have found a way to pool all of the idle resources that our storage nodes may have, and then we can maximize the returns for rewards on them. We can maximize the amount of information that we can store, and we can minimize the wasted resources across networks. We have a super fast data retrieval speeds, lightning speed data retrieval speeds. This is due to an improved architecture design, along with an integrated indexing functionality. Now, this makes CESS widely applicable for most, if not all, commercial use cases. We have a comprehensive API that is EVM compatible, but also is able to operate WASM smart contracts. Here's a small comparison for decentralized storage projects. I'm just going to let you guys read that for a couple seconds, and then I will discuss it a bit in depth. So we can see that CESS has an object storage service. Got a big tick for that one. Semantics-wise, we run a full CRUD. For proof of storage, we have our proof schemes, data reduplication and recovery. And this guarantees that we're going to have a very high replication guarantee. Unlike other protocols, you will save one file, and you will only get one copy saved onto a system. With CESS, we triplicate your file by default. So we're providing super high data assurance through that replication guarantee. And the proof of storage comes along with a challenge so that we can make sure that your data has not been tampered with yet as well. The storage cost is very low for CESS. I'm going to talk about that shortly. Our capacity is running amazingly. This is within our test net still. Our main net is to launch further along this year. And as you can see, we've had a massive adoption with storage nodes. This figure was taken from the 5th of June. So over 6,100 storage nodes have already joined our testnet and are currently actively mining CESS storage. Here we can see the Substats Blockchain Explorer. There we have the storage nodes. You can access all of this information through our GitHub, through our socials, through our website. Now, we're very excited to announce that in this last year, we've had major developments within CESS. We now have 3 products and services, Web3 services that have Web2 performance. So the first one is dShare. This is sharing made simple. Very, very simple way to share digital assets across to another peer. Then we have dCloud. dCloud is a way to access your data anytime and anywhere in the most private and secure manner. And finally, we have DOSS, which is what we're going to be speaking about today. It's our decentralized object storage service. DOSS is Web3 storage running at Web2 performance. So DOSS is a HTTP API storage, and it's for unstructured and metadata object retrieval. DOSS can use the whole network bandwidth instead of a single computer's bandwidth. So this is also the case when we're reading and writing these files. We can read the data from multiple nodes that are scattered within the system. We can assemble them from multiple nodes, and then finally we deliver those to the user. This is much faster than traditional computer reading and writing. In terms of scalability, because we store data in multiple nodes, and we have this guarantee of data integrity and data assurance, we create replicas, multiple replicas of all your data files. So this, paired along with our pricing model, paired along with our speed, provides a fantastic platform where you can securely and highly in an efficient manner scale up your ideas. We provide real-time data sharing through DOSS. We have a customized data management, and we provide massive storage. So a user can store up to 1,000 buckets per account. So if we look at the image to the right-hand side, a user can use the Blockchain Explorer to find out storage-related details. Now, this can be storage price, it can be the total available space, or the used space within the network. Once the user is satisfied with the price and he decides the amount of storage space that they would like to purchase, they can use CESS DOSS API to perform storage-related transactions like creating, deleting buckets, uploading, updating, and removing objects. DOSS interacts in a trusted execution environment. This is a TEE environment as we know it. And we interact in this environment to generate file tags. These file tags are stored by our storage miners. The consensus nodes then must create a challenge for these storage miners. And they're created at a regular interval. The storage nodes must then compute a proof to satisfy these challenges that the storage miner is currently giving it. This is to make sure that our data has not been tampered with. Once the storage node has provided these proofs to our consensus node, the consensus node will verify these, and that's where we get block generation. Here we have a small competitor comparison for the put speeds, or upload speeds, as we know them, for DOSS. So we can see we've got the projects. So our competitors, Filecoin, Arweave, Crust, and CESS. We've got the recommended tools, and down the middle, we can see the size of the uploaded file and the time it would take to upload said file. These are the test environments where we have run these tests. And finally, we have the put price. You may be able to see that CESS has a dynamic put price. This happens because with CESS, we can compute dynamic real-time pricing because we implement a mechanism that can compute the total amount of available space within the CESS network. So we've got an oracle that can also check our competitors' pricing, and this is how we determine our real-time dynamic pricing structure. Following, we have a competitor comparison for our get speed. So this is our download speeds. Again, we've got the projects, the recommended tools, the size of the download file, and the time it would take to download said file. Now, let's delve into the CESS architecture. So CESS has developed a new architecture where they have introduced 2 new miners into the system. So we have had the storage miner and the consensus miner, and we know how these operate. But we have also introduced now a retrieval miner and a cache miner. The cache miner is essentially acting as a buffer where we can have our hot data, the dynamic data that the user might have more needed, readily available access to. By separating all these jobs within our miner roles, we have achieved a more robust ecosystem, a more robust architecture, and it's a lot more secure, and it operates at a much optimized capacity. I'm going to talk about our proof of data reduplication recovery as well, because this is a very key aspect of CESS and the data assurance guarantee that we bring to our consumers. So, as I mentioned, with CESS, we triplicate your file by default. This is a guaranteed data recovery, and most importantly, guaranteed data integrity. We check periodically that your data integrity still remains the same, and then we can reassemble these through our different miners. So now let's look at smart space management. So this is great because it allows us to utilize all idle resources, bring in more value to the CESS network, bring in more value to the CESS miners, and bring in more value to our partners as well. So first of all, the storage miners need to specify the amount of space that they want to provide to the network and the directory where they want to store all of their files in a configuration file. This all happens at the setup phase. So that's the first phase, the configuration. Once the configuration of the storage nodes has been done, they can make their storage node active, so they can activate their storage node. The CESS Smart Space Management Mechanism can determine the storage-related information from that miner's storage disk. This includes idle data, idle space, archived data, active data, used space. This is then reported to the CESS blockchain, and we keep track of the available and used space within the CESS network. Finally, we have our consensus mechanism. Our consensus mechanism is called Random Rotational Selection Consensus Mechanism. We encourage open participation within CESS. All nodes have an equal opportunity to become candidate consensus nodes within the system. It is also a very energy-efficient system. We have low computational requirements for all of our consensus nodes. A selection of 11 nodes will be on duty every 24 hours. So when we do this, we guarantee that we're not having the same block generators over and over. That is, in a way, a form of centralization within block generation. So we will rotate our consensus nodes to make sure that this does not happen. Finally, this all happens in a credible environment. It all happens in a trusted execution environment. We also have implemented a credit rating for our consensus nodes. If they're not performing at an optimum level, these consensus nodes are going to be decreased in their ranking, and they may miss out on being selected to become on-duty consensus nodes. Now, there's tons of use cases for decentralized storage. We all need to build on it. We all have data to store. So first, we have customized network drives. We have one drive for all your needs where you can access your data anytime and anywhere. We have user-generated content platforms. CESS is empowering creators to fully own their data, but also to receive a fair share of revenue generated from said content. We could be a blockchain data backup hub. We're layer 1 and a layer 2 blockchain history data. We have snapshot update support. We have front-end support that can facilitate your journey. This is dedicated to front-end support for websites. We can host decentralized data marketplaces. And we want to bring the next generation of streaming medias onto the blockchain as well. Here we have a couple of development highlights that CESS is proud to be part of with Polkadot. Many of you may know, and if you do not, CESS has had a partnership and collaboration with Polkadot, where we have provided a decentralized storage substrate palette so that all of the parachains and all of the community ecosystem can all access our decentralized storage functionality. We have been building this for a few years, and it's now something that's readily available for everyone. We've won first place at Polkadot hackathons. We've been awarded not 1, not 2, but 3 Web3 Foundation grants. We have successfully completed the Substrate Builders program. We're proud sponsors early last year of the Polkadot Hackathon and the 2023 Polkadot Summer Hackathon as well that we have been sponsoring. CESS as well carries solutions beyond Web3, and this is something that is key to all of us for the mass adoption, not only of decentralized storage, but for the mass adoption of Web3. And we encourage companies in the Web2 environment to join on to this decentralization journey that we're going to be part of. This can be used for governments, it can be used in logistics, it can be used in live streaming, user-generated, created content. There's unlimited uses for all of these cases. This is a small snapshot of the team. We have been expanding over the last year a lot. We have team members almost in every continent at the moment, and we are taking part in events across the globe every month. Finally, I'd like to invite all of you to scan our QR code and be part of our story. Thank you very much.